Hey everyone. So in today's video, we wanted to give you a very brief and very simplified way of appreciating the role of different brain regions on the control of our anatomy. And so like, again, we take an approach that appreciates the interaction between the nervous system, the anatomy and the environment. And there are some that might organize their treatment and their assessments around trying to stimulate different brain regions, right, with their exercise interventions. But for us, there's far too much complexity within the nervous system, within the anatomy, within the environment to really think that we can target specific brain regions with certain exercises. So what we tend to do with IKN is we want to look at the interactions, the general interactions between different brain regions with our anatomy, and use those interactions as just one component to help guide our assessments, to help guide our interventions. So keeping it really simple here first, we're going to look at the interaction or the coupling behavior between the cortex, which is the highest portion of the nervous system, involved more so with conscious control of our movement, and with the cerebellum. So the cortex cerebellar coupling. The cerebellum is the part of the nervous system that's more heavily involved in coordinating our movement and refining the output from the cortex. So we can see the cortex represented here with the blue circles. We can see the left and the right cortex. And again, from a movement perspective, the cortex is more heavily involved with generating the intention to move and consciously controlling our movement. And this is also the portion of the nervous system that actually produces motor output. Whereas the cerebellum here pictured below with the yellow, orange and brown layers, this is the part of the nervous system that's more heavily involved with subconscious control and works to refine the motor output from the cortex. So obviously the language I'm using here is very different to how you typically hear us speak, because we're looking at things now from a top-down perspective, where the brain is actually acting on the body. But we know from previous videos that we also need to consider things from a bottom-up standpoint too. So looking at not just the nervous system anatomy interaction, but the environment and anatomy interaction too, where the environment drives movement. So it's about merging both these different strategies together. So, with our IKN approach, we obviously go into this in much more detail, but the functional organization of the cerebellum is really what guides us the most, because we ultimately don't want the cortex running the show. We don't want to have to consciously think about our movement all the time. And the cerebellum here, again, with the yellow layer, the orange layer and the brown layer, it's functionally organized in a way that coordinates the movement of body parts differently, right? So just like our anatomy and the architectural organization of our movement apparatus, there is a sharing of workload across the cerebellum as well, from medial to lateral or proximal to distal. So if we look at the image on the top right here as well, it gives us a kind of better insight into the location of the cortex sitting on top of the cerebellum as well. So if we look at this functional organization in a little bit more detail, and I'll explain some of the key points here along the way too. So the midline zone of the cerebellum, also known as the vermis, right? This is the yellow layer down the center, right? This is the layer of the zone of the cerebellum, the midline zone, that is more so involved with coordinating or refining the control of midline tissues or midline segments. So our eyes, our inner ear, our head, our jaw, our spine, our rib cage. And the key point with this midline zone is that this midline zone doesn't communicate very much with the cortex, right? And so that's why you'll hear us talk an awful lot about wanting the midline segments to express more subconscious behavior, right? But it's really not just about wanting subconscious movement, because that's what everyone likes to say, but it's more so about understanding where we actually need to distribute conscious control, right? And the more we move from the midline outwards, from the midline zone to the intermediate zone to the lateral zone of the cerebellum, the more those regions interact with the cortex, right? And so we move into the distal segments of our limbs. This is the region of our anatomy that interacts more so with the lateral zone of the cerebellum, which interacts more so with the cortex. So this is where we ultimately want that conscious control to be distributed, right? So we need to consider that functional organization as well. So if we move from this yellow layer, the midline zone, laterally into the orange zone, again, just to go through it in a little bit more detail, this is the portion of the cerebellum that coordinates the control of our proximal limb segments. So we're looking at the shoulders, the elbows, the hips, and the knees. And then moving even more laterally into the brown zone, into the brown area, this is the lateral zone. So this is the zone that coordinates the control of our distal limb segments. So the hands, the wrists, the feet and the ankles. And again, like I said before, this is the zone of the cerebellum that communicates the most with the cortex, right? And this is really important to understand for us, because this is why you'll hear us talk an awful lot about organizing movement around our distal endpoints, the distal segments of the limbs, because this is where conscious control or conscious awareness should naturally be when we're organizing real world movement, right? And you can think of challenges with movement coordination, or difficulties that we might have with movement coordination may arise when we actually lose the capacity to distribute that conscious control into the distal limb segments. And we might begin trying to consciously control our midline segments, like bracing our abs, or constantly trying to consciously control our ribcage position, for example. So it's not a bad thing. It's an important component, but from a top-down standpoint, we need to shift that conscious control distally to give all the other elements proximally the chance or the opportunity to express more subconscious behavior. So those are the really key points here as well, and we're going to talk about those in the next slide too. But again, I fully recognize that we're really simplifying things here as well, but appreciating these gender interactions, for us anyway, really helps to inform a much more robust assessment and treatment perspective, or treatment procedure, right? So the key points again: the midline zone, remember, the midline zone of the cerebellum, the yellow layer coordinates movement of the midline segments. Then we have the intermediate zone, the orange layer, which coordinates the movement or the control of the proximal limb segments. And the lateral zone coordinates the control of the distal limb segments, okay? And as we move from medial to lateral, or proximal to distal, these regions communicate more and more with the cortex. And we can use this functional organization to inform how we might need to load the anatomy to restore the capacity to share load. And again, this is looking at it from a top-down standpoint. And then we can merge that with more bottom-up strategies as well. Okay, so because the lateral zone of the cerebellum communicates more with the cortex, and remember that the cortex is the portion of the nervous system which is more heavily involved with conscious control of our movement, we ultimately want to work towards restoring that distribution of conscious control into the distal limb segments. So clinically, instead of trying to spend lots of time trying to make core exercises harder and harder, or trying to add more conscious cues to challenge things even further, to the conscious cues to the proximal regions, for example, as progressions, we should think about shifting that conscious awareness into the distal tissues as further progressions for the proximal tissues. Because if we can shift that conscious awareness into the distal tissues, it gives the proximal regions, the proximal tissues, the chance of the opportunity to express more reflexive, more subconscious behavior, okay? So this is really just a very brief insight to, I suppose, kind of use neurology to inform our treatment, right? We don't want to get overly complex. We don't want to try to memorize different neurological tracks to and from the body to the brain. We want to ultimately appreciate these general couplings, these general interactions, to guide how we can best organize our loading strategies. Now, of course, we can go deep into these concepts as well, which you get into on our courses, but we want to try and make things as practical as possible. Okay, so hopefully this helps you develop a little bit more of a better understanding of how we can use neurology or neurological concepts to guide what we do in a clinical and a training level.